Hello everybody and welcome back. We're looking at question number 22 in this video. Question 22 on the 2006 grade 10 Cayley contest. A positive integer is called multiplicatively perfect if it is equal to the product of its proper divisors. For example, 10 is multiplicatively perfect since its proper divisors are 1, 2, and 5. And 1 times 2 times 5 is 10. How many multiplicatively perfect integers are there between 2 and 30? Okay. So what makes 10 work as a multiplicatively perfect number? Okay. Well, 1's always going to be there no matter what number we're talking about. And then we really only have these two factors, 2 and 5, that just happen to make up 10. Okay? And if I take a look at, let's say, another number, at 12. If I take a look at 12 here, 12 has factors 1, 2, 3, 4, 6. 12 also there, but that's not the point. We don't include 12. If I take a look here, I can pair up factors as long as we're not looking at a square, by the way. And these guys are going to give me 12s. So this is actually going to, and the 1 never really contributes anything. So the product here is going to be 12 squared, not 12. Okay? The reason it works for 10 is we get 1, 2, 5. We don't include 10. And these guys pair up to give me a 10, and the 1 doesn't matter. So, to be multiplicatively perfect, we need exactly 2. The ones that aren't 1 or the number are called trivial factors. We need non-trivial factors. We need exactly 2 non-trivial factors. Alright, well, how do we get exactly 2 non-trivial factors? Okay, well, there's a couple ways we could argue this. One, I think you could probably argue that you're going to have them both be primes. Different primes, by the way. Actually, no. I was going to say it has to be separate primes, but let's take a look at 8. That's 1, 2, 4, and 8. And that gives me 1 times 2 times 4 is 8, because we don't count this last 8 here. So we need exactly 2 non-trivial factors. That's the only thing we can do. Well, is there a way to count non-trivial factors? Yeah, there is. It's actually easier to count just all the factors of a number, and then take off 2. 1 for 1, 1 for the n, the actual number. So I'm going to show you this. If you've ever seen this before, it's actually really handy. And, if it's your first time learning it, take it and go and use it somewhere. For any number n, we can write it as a product of primes. 2 to the 3 times 5 to the 1, that sort of thing. We can have as many of these as we like. Here. P1 to the E1, P2 to the E2, all the way up to PK to the EK. Okay? The number of factors of n is just E1 plus 1, E2 plus 1. And we keep multiplying. For every exponent, we just add 1, and then we multiply them all together. Okay? This is the number of factors. So the number of non-trivial factors. Actually, if we just need 2 non-trivial factors, we need 4 factors in total. Okay. So here's our expression for the number of factors. I'm not gonna go into why this works. We're doing a math contest, not teaching a math lesson. But it's a useful thing to have in your back pocket. It's something you're welcome to try and prove. Try small cases, check that it works, that sort of thing. So we need 4 factors. So now each of these E1s, which I'll call EIs, each of them has to be greater than or equal to 1. Okay? Otherwise, you're going to have 2 to the 0, and why would you even include that? And that tells me that each of these EI plus 1s is greater than or equal to 2. So if I have more than 3, or if I have 3 or more of them, I've got a product that's at least 8. That's not going to work. So 2 different primes. We could have E1 plus 1, E2 plus 1 equal to 4. E1 and E2 are going to both have to be 1. So it's going to look like P1 to the 1. It's just going to look like a product of 2 primes. Okay, and that's exactly what the 10 case is. Or we could just have 1 prime, and that would be sort of this 8 case. We'd have E1 plus 1 has got to be equal to 4. E1 is equal to 3, so n looks like a prime cubed. And now it remains for us to count between 2 and 30, and we'll flip to the next page. Between 2 and 30, how many of these? I'm listing them out just because it's a very short list. But how many of these are just a product of 2 primes or a power of 3 of a prime? It's 18, 19, 20, 21, 22, 24, and it was up to 30, right? Yeah. Okay. Well, we can just sort of get out our red pen and say, well, primes will not work. So let's get rid of all the primes. Uh, 23, 19, 17. Okay. So all the primes are gone. Now, prime cubes do work, so that's 8 right there, and 27, and 5 cubed isn't among the list. Okay, prime squares, that's going to go nowhere. And 16 is a prime to the 4th, so that certainly isn't going to work. He has 5 factors. There's 25 there. Okay. Now 6 has 2 factors. 10 we know has 2 factors. 12 we saw doesn't. It's got too many. It's 2 times 2 times 3. It's not just 2 times 3. 14, 2 times 7, that'll work. 15, that'll work. That's 3 times 5. 18, it's 2 times 3 squared, so it's out. 20's out as well. 21, 3 times 7, so that's still there. 22 is 2 times 11. 24 is right out, so is 28. 26 is 2 times 13, and 30 himself is gone as well. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 numbers in this range are multiplicatively perfect. All right, and that gives us an answer of A. Okay. So, yeah, not a whole lot to say. Interesting concept. I wonder how you would have tackled it if you didn't know how exactly we, what a fast way to count number of factors is. I suppose it is sort of a limited range of, multiplicatively perfect integers between 2 and 30. I mean, it was a short enough list for me to write out. I probably could have, if I didn't know what to do, just written out all the factors and started multiplying them. As soon as I get over, like if I started doing 30, I'll do 1 times 2 times 3 times 5 times 6. Oh, I'm already over 30. This one's out. So, that wouldn't have been so bad. Would have been longer, but we try and do our questions short, so we try and use our mathematical know-how. In the next video, we're going to be looking at question number 23. So join me for that one if you would like. You can also feel free to like or subscribe to be kept up to date. But either way, no matter what math video you watch next, I will see you there, and have yourself a wonderful day.